Hello, this is the Dynamic Signals Project. Here are the following team members.
Hi, my name's Keaton Eichhorn.
Hi, my name is Markel Malcolm, and I'm part of Group 2.
Hello, my name is Dimitri Jefferson, representing Team 2.
Hi, and I'm Joshua Fox.
So the goal in design was to build and test systems measuring distance and temperature using the Arduino platform and sensors. The requirements were a temperature measurement system, contactless distance measurement system, and a water depth system. The strategy to complete this was to split it up into 2 weeks. Complete the lessons in the first week, the intern report, and the intern videos, and collect all the data. The second week, we divide up the final report, put the video together, and have everyone approve of the outcome. By doing all this, we created the graphs needed and determined the outcome of the project. And here's a servo sweep. We followed the schematic and video that was provided to create this, and here's an example. So there's no calibration was needed, and an issue arose with Arduino board not being read by the program correctly, and we had to change the USB slots to get the program to run. Also, significance is that we learned from the procedure that you can program the servo to rotate at different degrees and to rotate back. A scenario you might use this is the need to create a robotic arm to move items at a certain degree to keep production moving. Water level. The schematic is pretty much the same as what happened with the US sensors. Follow the schematic within the respected lesson and then give priority to the sensor. And here's an example. So the water level. The calibration for this was done by comparing the first uncalibrated iteration to the true distance. The graph was then broken into linear sections. If a value fell within a linear range, then it was interpolated and added to the range's minimum. And here's a water sensor pre-calibration. And the possible errors include measurement error due to refraction, ruler out of water, sensor in water, and then notice that the longer the sensor ran, the fuzzier the numbers became. This is not included in the data. And here's the calibrated graph with the 5 iterations and then the true. The significance is that we learned how to set up and conduct an experiment calculating the depth of the water, learned how to interpolate based off the values we were receiving and adding them to the range's minimum. A scenario is you need to measure the water level of a container, then you can use a sensor to get accurate measurements at different levels. The US sensor. Schematic follows the same approaches as in the lessons, however the servo 5-volt connection was replaced with 3.3 volt, and here's the example of that. So the calibration was not needed for the US sensor because it matched the true distance, and the only error for the US sensor was the dial spinning backwards. So instead of showing distance from wall, it displayed the distance to the 50 centimeter mark. And here's the graph that showed the distance and the measured distance. The significance is that we learn how to measure distance by using a sensor compared to a ruler. Scenario: need to measure distance that isn't reasonable to measure with a ruler, such as land and surveying crews. Thermometer with LCD screen. The schematic should be the same as the lesson, however the potentiometer was connected to the breadboard with male and female wires. And here's an example. The thermometer with LCD screen. Calibration was not necessary when the data was collected. Pretty much the same story as the US sensor calibration. The thermistor was slow to change temperatures, therefore the low temperatures are not accurate, could be improved by leaving on the ice for longer. And so here's a graph of the pre-calibration and what's measured and what was actually thought. And the significance is able to project the temperature using an LCD screen and learn how to take temperature using a thermistor. Scenario: you still know how to use a thermistor if you need to protect a circuit from getting too hot or too cold, potentially saving it from being ruined. And that concludes the group project.